Hi, I'm Charles Germany. We've been talking about network media and cabling, shoulder twisted pair STP, unshoulder twisted pair UTP. Today we're going to make some cables, a straight through and a cross through. We have some category 5 wire, or category 5E that I got from Home Depot. Pretty inexpensive, you can find it cheaper online. We've got some rj45 endings for phone wire, if you're going to use category 3 for phone wire. And we have some rj45 endings that will crimp on to our category 5E wire for cabling. To start with, you need to strip the insulation jacket back on the wire. So you select the length or piece that you need, cut it from the cable. You can use crimpers, you can use strippers. A lot of times the category 5E crimpers will have strippers on them. My personal favorite is just a small little razor blade or utility knife. I'm just going to go through and slit an opening here in the insulation jacket, and I'll try to hold it at an angle so you can see. You just want to try to be careful that you don't slice any of the insulation off the wires inside. And I don't want any of them to short out against the others. Peel the insulation jacket back and we'll see that there's a little bit of fiber in here to give it some rigidity. I'll go ahead and trim this off. I'll pull these out so you can see them. And spread them out. You can see that they're twisted together, and hence the term UTP or unshoulder twisted pair. The reason they're twisted together is to reduce what we call crosstalk in the wires. Now, as the electrons flow down the wires, oscillating in both frequency and amplitude, and corresponding to packets or datagrams, they create an electromagnetic field. Anytime there's a flow of electrons, it creates a magnetic field. Well, when wires are put so closely together, those magnetic fields can interfere with each other. So by twisting them together, it helps the fields cancel each other out. And that helps to cut down on the crosstalk. And so you can basically get longer lengths of cable. Now remember, you're limited to about 100 meters with category 5E. Not just because of crosstalk, but there's also signal attenuation. Attenuation is the tendency of the electrons to be absorbed into the media after a while. Basically they're converted to waste heat or entropy. So if you don't have an active hub or a repeater or a switch every 100 meters, then that signal would basically lose its integrity. It would become so weak. So we're limited as far as how long a cable we can make, and it's just a good idea to twist them together to eliminate that crosstalk. Now I'm going to untwist all these so we can take a look at them. And it doesn't really matter the colors that you use or what you use first, as long as you basically make sure that you run transmit to transmit and receive to receive in a normal cable, and you want to run transmit to receive and receive to transmit in a crossover cable. There are 8 wires in category 5E, but only 4 are used. And we're going to use, in this case, wires 1, 2, 3, and 6. And in most standards, there's several different standards. Again, remember I said the color doesn't matter, but it helps sometimes to have a standard, or it makes it more convenient. We're going to use the A wiring standard in this case, and that would be 1, orange-white for 1, orange for 2, green-white for 3, and then 4, 5, 7, and 8 are not used, but green would be 6. So we'll transmit signals on 1 and 2, and we're going to receive signals on 3 and 6. Like so. So let's go ahead and do that. We'll take orange and orange-white. I want to move them over to the side, line them up like that. And then we want to take green, white, and blue. We're going to move green, white over here. And blue. And then blue, white, and then wire 6 will be green, if you can see that, I'm lining that up. If not, I'll rotate it so you can see it better. Then we want to go brown, white, and brown. And then I'm just taking my thumb, I'm kind of pulling it or putting tension on it with this finger, and then I'm pressing down here to try to line these things up. Okay. I'm going to trim off the edges. See how they're crooked like that? We want these things to go inside the end in a very even fashion if it's possible. So we want to trim those off. And again, that's where a pair of shears comes in handy. And we just want to check at this point our wiring. Things can tend to get twisted around sometimes. So here's our orange, white, orange, our green, white, our blue. There's our blue, white, our green, our brown, white, and our brown. And again, I'm going to trim these just a little more. About a finger's length and a half from my point of view. Now, in this case, I'm going to hold the end here. This is rj45 end. And you'll notice there's two sides. Here's the little tab that clips into the NIC interface or the internet card. Here are the metal, in this case these are the metal terminals that make contact with the pins inside the NIC interface or the NIC card. Well, this side, there's sort of a transparent window here. I kind of call this the belly of the end. This is where we want to go ahead and insert our wires. See, there's little grooves here that will catch the wires as they're inserted. We want to insert them evenly so they press up against the edge here. And you'll see these little metal pins, when we crimp, they're going to go down and pierce the insulation of the wiring, and then that'll make contact for the circuit so that they can transfer electrons. So I'm going to go ahead and push these up in here. And then now you can see how they're all against the end there. And all against the end. And that's good, but I've still got it a little bit too long. And the reason is when I crimp down, you see this little section here on the end? We want to get the insulation jacket just behind that. And then that'll crimp down and hold that insulation jacket. And this will make this a much more durable cable because, you know, in usual wear and tear, if it weren't for this little piece here crimping down on the jacket, this would tend to pull loose over time. So I've still got them just a little bit too long. So I'm going to pull them out, hold them with both my fingers, straighten them a little, and I'm going to trim them. I'm going to take off about a 1/4 inch there maybe. And I want to straighten them again. Anytime you do this, you probably want to check your colors. Orange, white, orange, green, white, blue, blue, white, green, brown, white, and brown. So again, I'm going to take my rj45 end, and I'm going to carefully insert them in there. And now I can get my insulation jacket up past this tab. So I want to also take a look at the sides and make sure my wires are making contact. Their brown is making contact all the way to the end. Their orange, white is making contact all the way to the end. Check your colors, orange, white, orange. In this case, we have green, white, blue, blue, white, green, brown, white, and brown. And also check the end from this perspective and make sure that all of the wires are meeting the end there. Eyesight's not that good, so at your expense, let me see. Okay. Now I can show it back to the camera. Alright, we're going to take our crimpers. These are some pretty cheap crimpers, bottom at Radio Shack. You can get much nicer ones if you're willing to pay a bit more money. The best ones are the ones that have a weighted block on them. So I want to take my rj45 in, it goes inside here. I want to apply some pressure, push the cable on the wire towards the crimper, towards this way, so that it's got a good, firm connection. And then I'm going to press down, and when I do, it's going to press on all those metal pins, and it will press them into and pierce the insulation jacket of the wiring. And that'll complete the circuit when we plug our cable in. So I'm holding it in, and now that I've got it down, I'm going to give it a little pressure. Just going to give it a good firm amount of pressure. Not too much, you don't want to break the plastic tab off, but you definitely want to make sure that those pins lock in place there. Okay, and now you can see that I've grabbed my insulation jacket there, so it'll be a little bit more durable, it won't pull loose.